Yes, dear children, in the previous class, we had understood about how to balance chemical equations. Hope you all have balanced the given workout problems that was very easy to solve. Now, let us move for further concepts in the chapter chemical reactions and equations, that is, types of reactions. Coming to the types of reaction. In our day-to-day life, there are many reactions occurring and they're broadly grouped into 5 to 6 types. Let us understand about each of those types of reaction in detail. First one, it is about combination reaction. What is combination reaction? As the name itself says, it's a reaction in which single product is formed from one or more reactants. Product should always be one, whereas reactants will be two or more. So we can represent it as A plus B giving AB. A plus B giving AB. This is the general representation of combination reaction. Now, coming further, let us know one example for this combination reaction. Yeah, one activity which is mentioned in your textbook, that is, take a small amount of calcium oxide. This calcium oxide is also called as quicklime. It's also called as quicklime. Quicklime. Okay, you should remember this. So this calcium oxide, which is also called as quicklime, is taken in a beaker. Okay. To this, slowly we need to add water. When we slowly add water to this, we'll find that when we touch the beaker, it's becoming hot. That means heat is released. Along with that, there will be formation of product. Reactants here are calcium oxide and calcium. Reactants are CA, CaO plus H2O. When this CaO plus H2O combines, what would be the products? Can you guess it? Yes, the product here formed is calcium hydroxide. Children, can you guess the formula of calcium hydroxide? Yes, calcium hydroxide formula is CaOH twice, CaOH twice. So this calcium hydroxide is the only product formed when calcium oxide mixes with water. And this calcium hydroxide is called as slaked lime. So quick lime combines with water to form slaked lime. And here you should remember one more thing. Here in this particular reaction, temperature has increased. That means heat got released. Okay. Yeah, you can see the image. Beaker is there. In the beaker, water is taken and calcium oxide powder, white color powder is added. When the beaker is touched, it has turned out to be hot. That means heat is released. Along with the single product, that is calcium hydroxide. Dear children, heat is not the product, it is just the change in temperature. Let us watch a video related to this. Yeah. Okay. It's not playing. Let's move further. Yeah, let us now understand how to write the equation for this combination reaction, which I have already shown in the previous slide. That is calcium oxide, quicklime with water produce calcium hydroxide, which is slaked lime. CaO with H2O giving CaOH twice. Dear children, can you observe something here? Look at my cursor, arrow mark. Inside the bracket, there is some letter S, L, A, Q. What are these? These are nothing but state of matter in which the reactant and product will be present during the reaction. So CaO is in solid form, so S is given. Water is in liquid form, so L is given. If gas is there, what would be represented? What would be the designation given? Yes, it would be represented as G. Then what is this AQ? AQ is represented when the particular reactant of the product is in solution form where the solvent is water. When some reactant or the product has dissolved in water, then that's called as AQ, which means aqueous. It means aqueous. Aqueous. Aqueous means solution in water. When the solution is in water, then it is called as aqueous. Hope you have noted it down. Okay. Now, let us move further. In this reaction, calcium oxide and water combines. So the combination reaction to form single product, that is calcium hydroxide. Large amount of heat is produced in this reaction, and when heat is generated in a reaction, such reactions are called as exothermic reactions. Okay, let us move further. Yeah, there's one important thing that you need to note, that you need to know. That is a solution of slaked lime. Slaked lime means calcium hydroxide, a solution of slaked lime produced during the combination reaction of quicklime and water. That slaked lime is used for whitewashing the walls. Dear children, you might have observed whenever a new building or new home, new house is constructed, before painting, it's always whitewashed, right? During whitewashing, have you observed one thing? During whitewashing, generally on the first 2 days of whitewashing, the color of the wall remain colorless. It will be as same as the cement color, which is been plastered over the wall. It will not have any color. After 2 days, generally it will gain white color. What would be the reason? The reason is calcium hydroxide reacts slowly with carbon dioxide present in the air. Okay, and that calcium hydroxide, when it combines with carbon dioxide present in air, it will form calcium carbonate, which is white color. And this take a little time for the formation. So calcium carbonate of the white color of the wall do not appear as soon as the whitewashing is done. It takes 2 to 3 days of time. It gives shiny finish to the walls. That's why before we apply paint, we will whitewash the walls to give that shiny finish. Here is the reaction. Calcium hydroxide, CaOH twice, AQ means aqueous, plus carbon dioxide, G means gaseous, giving calcium carbonate, S means solid, plus H2O, L means liquid. So this particular reaction indicate whitewashing of walls, and calcium carbonate is the reason for white color of the wall after 2 to 3 days of whitewashing. What are the other examples of combination reactions? You have already understood one reaction, burning of magnesium ribbon. Magnesium, when combines with oxygen, form magnesium oxide, white color ash, and that's a combination reaction. Single product is formed. Another example, burning of coal. C plus O2 giving CO2. Formation of water from hydrogen and oxygen, H2 plus O2 giving H2. Along with this, one more, what I said, Mg plus O2 giving MgO, magnesium oxide. Exothermic reaction. I said a word exothermic reaction in the previous slide, right? Exo means out. Thermo means temperature. That means temperature is released out, given out. That is called as exothermic reaction. There are many reactions that takes place in our surrounding where the heat is given out, and such reactions are always called as exothermic reactions. One example we have just seen, combination reaction between calcium oxide and water is exothermic in nature. Reactions in which heat is released along with the formation of products are called exothermic reactions. Example, burning of natural gas. When you burn the natural gas, that may be even any fuel for that matter, burning. When you burn it, it produces heat. So it's a best example for exothermic reaction. When you burn a candle, exothermic reaction. When you burn LPG, exothermic reaction. So here is the image showing burning of natural gas, exothermic reaction. Then respiration. Dear children, let us do a simple activity. Take your wrist, okay? Take your fist, okay? Folded hand. Bring it, close your mouth, okay? Bring it below your nose. Don't open your mouth, okay? And continue to respire. What do you feel? You feel that your fist is becoming hot. That means fist is feeling heat released by our nostrils. Okay. So respiration, during respiration, it releases heat. Then decomposition of wastes. Whenever you go to your backyards and try to clean up materials that's near your garden, you may find that many leaves have fallen below the trees, and you go to pick them up. Okay, when you go for picking it up, you will find that the bottom layers below the dried leaves and decaying leaves, it's hot because during decomposition of any waste, it will produce heat. So it's called as exothermic reaction. So these are the other examples of exothermic reaction. One very important question that may arise for your main examinations that you need to note down is, why is respiration called exothermic reaction? Why is respiration called exothermic reaction? You need to note it down, children. This is also, you can consider it as homework. Okay. Why is respiration called as exothermic reaction? Find out the answer. It's very easy. Okay. Yeah. Let's move further. Here you can see tomato, which is the costliest now, right now actually, costlier one. This tomato is decomposing, decaying. During this decaying process, it will definitely release heat, hence it is called as exothermic reaction. Let's move further. Then, second type of reaction is decomposition reaction. Combination, combine. Decomposition, divide. It's just opposite of combination reaction. In combination reaction, I have said you that in combination reaction, the equation will be as if A plus B giving AB, right? This is for combination. Whereas for decomposition, it is like AB giving A plus B. This is for decomposition. Okay, that you need to observe carefully. Here it's just the opposite of combination reaction. Decomposition is opposite of combination reaction. Okay, let's move further. Exact definition of decomposition, let us understand. A type of reaction in which single reactant breaks down to give two or more simpler product. There, reactant was two or more. Product was only one. Here, reactant is single. Observe here, reactant is single. Products are two or more. That's decomposition reaction. This decomposition reaction, we can group into three categories based on what type of energy is supplied for breaking of that reactant. When any reactant is undergoing breaking, decomposition, it requires some energy definitely, either in the form of heat or in the form of light or in the form of electricity. Okay. That's why we can consider decomposition reaction require intake of energy. Okay. So intake of energy, when it is there, we can consider it as endothermic reaction, opposite to exothermic reaction. So let's know what are those three types of decomposition reaction. First one, thermal decomposition. Can you guess what type of energy is supplied here? Yes, you have guessed it right. Thermal means temperature. That means heat is supplied here. Second one, electrolysis. Here, electricity is supplied. Third one, photolysis. Photo means light. So, in photolysis, light is supplied. So, these are three types of decomposition reactions. Let us understand about each type. Thermal decomposition reaction. What is thermal decomposition reaction? A type of reaction in which heat is supplied to break the reactants. Heat is the source of energy. It's endothermic reaction. Endothermic because heat is supplied, not released. It's not given out during the reaction. Instead, it is taken inside during the reaction. Hence, it is opposite to exothermic, that is endothermic reaction. Now, here you can see one of the activity given in your textbook that we need to take 2 grams of ferrous sulfate. Ferrous sulfate is represented as FeSO4. Okay, FeSO4 is taken. And this ferrous sulfate, it's green color, pale green color crystals. Pale green color crystals. Okay, so it's taken in dry boiling tube. Note the color. I have already given here, it's pale green color. Then heat the boiling tube over the flame of burner or spirit lamp as shown in figure. Observe the color of the crystal after heating. You can see here, dear children, what this girl is doing. Whenever we are burning anything, the burning content which is releasing the gas should be away from our face. This is one laboratory precaution. Whenever you are doing any activity in the lab, the burning component or the material which contain the burning component should be apparatus, should be away from our face. And she's wafting the gas gently towards the nose. Whenever we are cooking or doing anything in our daily life, if we want to smell it, we'll just take and smell it, right? But in chemistry lab, you're not supposed to do it. You should just waft it. Okay, you should take the smell like this, wafting the gas gently towards the nose. Do not point the mouth of the boiling tube to your neighbors or to yourself, because they all contain chemicals and definitely poisonous gas can get released. So here, this FeSO4 is being heated. Okay, when this is heated, pale green color crystals turns into brown color. It turns into brown color because it undergo a decomposition reaction and it produce products, which is not just one, but it is three. Let us know it further. How this decomposition happens, let us understand the theory part of it. Ferrous sulfate crystal, it's represented as FeSO4.7H2O. You need not worry about this part of the formula right now, 7H2O part, because we'll discuss about that in the coming chapters. Okay, FeSO4 crystals, that is ferrous sulfate crystals, will lose water when heated and color of the crystal will change. It will lose this 7 water molecule when heated and it will lose its color. That means pale green will turn to white. Later on, further heating, then it decomposes to three products I said. One is Fe2O3, another one is sulfur dioxide, another one is sulfur trioxide. This Fe2O3 is actually brown in color. Ferric oxide, which is brown in color. That's why on heating pale green ferrous sulfate crystals, it turns to brown color substance, which is nothing but Fe2O3, whereas SO2 and SO3 gases are released out. Ferric oxide is a solid, while SO2 and SO3 are gases. This is about thermal decomposition reaction. There's one more example given in your textbook, that is burning of or thermal decomposition of lead nitrate crystals. When lead nitrate crystal is heated, it will also divide into three products. Lead oxide is produced and NO2 gas and oxygen gas. Three gases are released during decomposition of lead nitrate. Lead nitrate on decomposition produce lead oxide plus nitrogen dioxide plus oxygen. So these are three products of decomposition of lead nitrate. Okay, three products are produced. And here also heat is supplied. As heat is supplied, obviously it's called as endothermic reaction. Okay, now let us move for another concept, another type of decomposition reaction, that is electrolytic refining. Sorry, electrolytic decomposition. Electrolytic decomposition, or in short called as electrolysis. Electricity is the source of energy. In thermal decomposition, heat was the source of energy. Here, electricity is the source of energy. Electricity will break the reactant into two or more products. Single reactant will be there. One best example is electrolysis of water. When we pass current to the water, it will break down into two products. One is hydrogen gas, another one is oxygen gas. You can see the sector. A mug is taken and two hole is done at the bottom of the mug, and two graphite rods are kept inside, to which test tube is covered upside down, inverted, and water is taken. And the wires from the graphite rods are connected to 6-volt battery. Okay, dear children, one thing you need to remember, in the battery, whichever side is connected to the negative terminal of the battery, you can see the symbol here, it's given negative. It may not be much clear for you, but here this terminal is negative. Okay, negative terminal, the wire connected to negative terminal is called as cathode, and the graphite rod connected to positive terminal is called as anode. Okay, and when the current switch is turned on, then bubble starts to appear on both the test tubes, even in cathode side and even in anode side. Okay, what would be those products? One side it will be hydrogen gas, and another side it will be oxygen gas. Water, and breaking down, it produces H plus and OH minus ion. So we have understood more about this electrolytic decomposition reaction. We have just understood a little about electrolytic decomposition reaction. We'll discuss more about this in the coming video. Thank you. Hope you liked it.